Before we move on to looking at some of the other sort algorithms, I want to introduce the concept of a stable versus an unstable sort. When it comes to sort algorithms, there are stable sorts and there are unstable sorts. So what does this mean? Well, stable versus unstable comes into play when you have duplicate values in the data that you're sorting. For example, I have an array on the screen here and it contains 2 9s. There's a 9 at position 1 and there's a 9 at position 3. So the question is, when we sort this array, will the original ordering of the 2 9s be preserved? In other words, in the sorted array, will the white 9 still come before the black 9, or will their positions have changed so that the black 9 comes before the white 9? If a sort is unstable, then that means the relative ordering of duplicate items will not be preserved. And so in an unstable sort, the black 9 will end up coming before the white 9. So what will happen is the 9s are sorted now, the array is sorted, but the 2 9s have flipped position. Their relative ordering has not been preserved. So in the original array, the white 9 came before the black 9, and in the sorted array, the black 9 is coming before the white 9. And so when this happens, when the relative ordering of duplicate items is not preserved when you sort, it's considered to be an unstable sort. And you'll see that some of the algorithms we look at are unstable sort algorithms. Now, by contrast, for a stable sort, we're starting off with the same array, but after we've sorted, the white 9 still appears before the black 9. So the relative ordering of the duplicate items has been preserved, and in this case, it's a stable sort. Now, all other things being equal, a stable sort is preferable to an unstable sort. Now, you might look at this and say, well, who cares if the relative ordering of the 9s flip position? And for integers, it doesn't really matter. A 9 is a 9 is a 9. But if you're sorting objects, it could make a difference depending on how you're using it. For example, if you want to do a sort within a sort, so for example, you may first sort based on name and then you want to sort based on age or something. Well, if the second sort causes the positions you got from the first sort to flip, that's going to be a problem. So for integers, it doesn't matter. And depending on how you're using the data, it might not matter, but in some situations it will matter. And you're not going to want a sort to change the ordering of duplicate items. And so as we go through and look at the sort algorithms, we'll think about whether they're stable or unstable. So how about bubble sort? Is bubble sort a stable sort algorithm or an unstable sort algorithm? Think about this for a minute. Think back to the code and how bubble sort works. The answer is that bubble sort is a stable sort algorithm. And why is that? Well, when we're comparing adjacent elements, we only swap them if the element at I is greater than the element at I plus 1. And so when those 2 9s end up next to each other, and they will eventually the white 9 will end up at position I and the black 9 will end up at position I plus 1. And when we compare them, because 9 is not greater than 9, we don't swap them. So their positions remain the same, the relative ordering. If the algorithm said greater than equals, or our implementation said greater or equals, then we would swap them, and that would be an unstable sort. And you don't want to turn a stable sort into an unstable sort, and it's really easy to do. And I have seen cases around the internet in blog posts and things like that where a stable sort algorithm has been coded to be unstable. That pesky little equals can make a big difference. So be aware of this. Be aware of this when you're reading code on the internet, and be aware of this when you're writing your own code. Make sure that if a sort algorithm is stable, that your implementation isn't inadvertently changing it to an unstable algorithm. So in a nutshell, a stable sort algorithm preserves the relative ordering of duplicate items, and an unstable sort algorithm does not. And on that note, let's move on to the next sort algorithm. I'll see you in the next video.